This week we're celebrating Pi Day 3.14159, and we're talking about new ideas. We're redefining our hypothesis definition for the scientific ladder of ideas and explaining why we think testable hypotheses are better than those that can't be. Hello everybody, welcome to the podcast. This week we're going to be doing a Thoughts from an Engineer segment. Real quick, I'm going to share my thoughts. There's, even from the last episode, I say this a lot, but there's a lot has happened since the last episode. So we're recording this here on Pi Day, March 14th. I only know by the number, 3.14159, because that's how nerdy I am. Yes, I have memorized pi up to, 6 decimal places? But that is only because I am so nerdy that the college that I went to, pi, the number, the universal constant, was in our fight song. So, so if you ever wonder just how nerdy you can get, I've probably gone there and passed it. So we're here today. It's so funny going back to thinking back to those days and college and thinking about like why I got into this. It was a real great conversation with Avi Loeb, the astrophysicist that we talked with on our last episode about Oumuamua, the first interstellar object we've ever actually witnessed come through our solar system. And it really made me think back to like why I got into science in the first place, which I think is a real testament to how great that interview was and how much I enjoyed it. And I've heard a lot of things from you guys, so thank you so much for letting me know that you liked it. I want to talk to more people like Avi. I want to talk to more people who are doing research, who want to share what they're doing, share what they're passionate about. I mean, you could hear it in his voice. I try to bring that across in my voice every week. But like pi, for instance, right? Let's take Pi Day and let's use it even more than I already did, because if you're following us online on Instagram at Today in Space Pod, our AG3D printing lab at AG3D printing, wherever you find us online, we threw a bunch of content at you for Pi Day. And, we designed a part, literally every feature. Here it is. Here's our Shrine of Pi here, which has a 3D, it's all 3D printed, but we have a 3D Pi on the back. We have 3.14159265358. Yes. Again, I warn you that I was beyond nerdy. So, regardless, I was looking for a bunch of bottles online. This is the one that I actually designed myself. If you go to our Instagram page, our Facebook page, whether it's Today in Space or AG3D Printing, you can actually see how we designed that and everything about it. I'm going to try and release more content like that, show people what's possible with 3D printing. We're doing that with AG3D, but I think there's a laser focus thing that we can do. Regardless, I'm going on a major tangent here. I was designing this Shrine of Pi and using like that number 3.14159 and it was like multiples of that, and that's how I designed this whole thing. It was just an interesting thing to like dive into and see would it work. And it was interesting to think about, like that's one of the great things about scientific discovery, right? Using the scientific process to whittle down, and like when you find something interesting, like Avi did with Oumuamua, or like the constant pi that was found, where they could divide any circle's circumference over diameter, and they would get pi every single time. And like that's what great science does. Is it discovers something. You look at it, you go, "Ooh, that's interesting," then you dive into it and you discover it. Of course, now pi it's a universal constant. We use it for mathematics, for physics, for almost damn near everything, and it's just something we found, right? We did good science. It's a repeatable thing that you can test, and you're always coming up with the same number. And like the crazy thing about pi is, I think it's like 6 million. They calculated it to like 6 million places or something, decimal places, right? And that's still not the end of pi. And there was some really interesting graphic, like artistic representations of pi, where they took the numbers, the repeating numbers that have been calculated already, and created some amazing art with it. And that's the wild thing about how when you really go deep into mathematics and science, how much art there is with the science, even though sometimes it can really just come across as dry. Even me, like I self-deprecate about about being nerdy all the time. I legitimately had, like, I don't know, for a super long time, and this podcast helped, but for a super long time, I like didn't want to admit that I was nerdy. Like that's that's a whole nother thing. That's my problem to figure out. But that's what I loved about talking with Avi, and why this podcast exists is because, like, let's share that excitement that we have for it. I mean, one of the things that kept me in science was a science teacher that just made it interesting, right? And that infectious excitement about any topic. It doesn't have to be science, it doesn't have to be engineering, technology, math. It could be anything. When someone's excited about it, it just makes you want to listen a little bit more. So, again, going back to what I love about science is that it really is this tool for observing reality. And even though we're humans and we'll always miss just a little bit of what the real thing is, or what the pure reality is, we'll never get to 100% because we're human beings, we're apes. I had to remind myself of that this week. I literally was just like having a hard week, a bunch of pain and stuff like that, and then I realized through the help of other people in my life that I'm not drinking nearly enough water, and like started drinking more water, and voila, I feel better. Again, we're human beings. Like, we can't get over the fact that we're apes, that is our limitation. And if we're okay with that, then the universe becomes something you can explore and go through. But if you think it's something that you have to be this machine, this robotic thing, then it becomes very dull, very boring. And I mean, I think it's what a lot of people, I mean, even myself, like taking tests, killed so many dreams of people in science way before they even started, because they just, I mean, I had such a thing about taking tests. If someone tries to quiz me, I lock up, my brain stops working, and I forget everything. That's like, this podcast has been cool to like go back to what I care about, what is awesome about science. And so Pi Day was, I really went in. I really went for it. So if you want to check all that stuff, you want to learn about 3D printing, go check us out over there. And the other thing that I want to talk about this year, and more thoughts that I wanted to share here, is this idea about hypothesis and the scientific ladder of ideas, right? So anyone that's new, or if you're just new to the concept, we don't do it every week, but we talk about this scientific ladder of ideas, right? Scientific ideas start as hypotheses, and then once they're testable and you get good results, they become theories, scientific theories. And then that becomes an even sharper tool for you to cut through reality and figure out what's there and what's real. One of the famous things is Einstein's theory of relativity, right? First one, special relativity, it did account for some of the equations of the universe. Of course, he was trying to come up with the equation for the universe. And then he ended up, even though he was able to find some things with the theory of relativity, it still didn't account for all of that. So he tweaked it, and it became the theory of general relativity. And then he was able to find the test with the eclipse of the sun and watch the light curve around the sun, right? Watch the stars behind it curve around the edge to show that the mass of the sun was affecting space and time, was literally curving what we saw, curving the light behind it. And I've been very bullish on the idea that, I use a scientific ladder of ideas for how I care about stuff. And I had really given everything that was in the hypothesis section kind of just a general swipe of the brush. And this week I wanted to add on to that definition, tweak it, because even my definition, after talking with Avi last week, I realized, especially after some things he was mentioning, that I was putting them into a bucket. I was generalizing too much. So hypotheses are ideas, right? And I was saying that how much I would care about a hypothesis depended on, or how much I would care about a scientific idea is, and I was usually talking about string theory and simulation theory, like all these crazy ideas that make us think about the universe and explore new ideas, which is great, right? That's what you want from a good idea. But we don't have any idea how to test something like that. How do we test that there are other dimensions and that it's all a bunch of strings of dimensions that come through to make our reality what it is? How do we test that? How do you put that in the lab and then replicate it and then have other people do the same thing so that it goes up the ladder so that it becomes more? And that's what I was originally talking about. It's like, I think it's exciting. I think string theory is exciting, but there's nothing, there isn't any way for us to test it. So how can I take that idea and like make it a part of my life? I can't. There's not enough. You can't even show me that you're correct. Again, great idea. I'm not downing it, but that's it. And Avi's hypothesis with Oumuamua about potentially being some object that we've never seen before, given on what they've observed, right? We talked about it extensively in the last podcast. So if you haven't listened to it, go to the last episode, listen to that, and definitely come back. But what it's shown us, the fact that this thing is showing us Oumuamua is, and it's gone, right? It's gone way past us. We can't even launch anything to catch up with it. That's how fast it's going. It's beyond us. But there's an opportunity for these other objects to come through. If this one came through, it's probably not the only one. So what we need to do, and this is Avi's next step with his hypothesis, is let's launch a rocket the next time one comes through and has a spacecraft on it that has a camera, and then we can basically, catapult our rocket with the spacecraft on it to catch up with that, and then it'll take pictures of the object, and it can continue with that object outside the solar system and keep sending us data back. Obviously, that would take a long time if it's something as fast as Oumuamua. The longer and longer it goes past that it passed us by, the more and more time it's going to take us for data to come back, right? We saw with the Perseverance rover landing that it's, roughly 11 minutes for data to come back and forth from Mars, and that's a pretty consistent position. Yes, it changes, anywhere from, I think it's like 7 minutes to 11 minutes, depending on how close Mars is from us, but that's something that's repeatable. Once that thing keeps going, it's going to take us longer and longer to get pictures. But we only need a few pictures from the beginning to see something like that, right? Because the problem with the Oumuamua was it came through so fast, it was too far away for us to really resolve it with any telescope that we had. And so we only have the data that we have, and based on what he's pulled together from all these other people that have done their observations, right? A scientific community pulling together to say this thing is weird. It showed that it's not like anything we've ever seen before, and it's from what we're seeing, it's probably this less than a millimeter thick, big, like pancake shape, big, long and thin light sail, highly reflective. It represents what we would think of as a light sail, but like Avi was saying, it might even just be something that was like the outer surface of something that got broken up. So basically, we are seeing something that we could be getting interstellar trash, right, from other old civilizations that are coming in, that are just caught up in the gravitational loop of things that we might be picking up. It might even be some kind of beacon that another civilization has put out there that goes around the stars, and then it kind of maps or lets them know where everything is, right? And this idea is just not being taken anywhere near as as seriously as something like a string theory that can't even be tested. Avi's hypothesis can be tested in 10 years, right? If we give enough time. I think he was doing them in the book Extraterrestrial. He talks about all like the odds of this thing that came into our solar system, the odds of that thing being here, and basically that if that one showed up, then there's a high likelihood that there's a lot more, and what we just need to do is have eyes out there to catch the next one that comes by. That's way more promising of a hypothesis that could become a theory, because it can actually be tested. We can today put out a rocket with a spacecraft on board that could pick it up halfway there. I did want to ask him if it's also possible to put spacecraft out in certain points, like even Lagrangian points, right, where potentially they may be these pockets of gravity where if you place like a station at L2, right, Lagrangian point 2, then it's pretty much going to stay there because the attractive forces of gravity counteracting, and there's this pocket where everything just kind of stays. And would it make sense to put a spacecraft out there that has a camera so it can take pictures of things as it's coming through those pockets of those Lagrangian points, or does it make more sense just to launch one as fast as possible as this one comes in? But I am so about this idea of let's test it, right? Let's go out there. We have the capability today. SpaceX, I was just checking out this tweet. SpaceX this year, on average, 2021, has launched a rocket every 8 days. And they're like the only one right now that could be quick enough to react to a mission like what Avi is talking about, where we need to launch a spacecraft and get it out there. Obviously, the spacecraft would have to already be built and basically ready for any time for it to launch, and that would have to be something special that would be done. But we finally have the capability that we could actually test something like that. And the fact that that rocket, the Falcon 9, would be even cheaper than sending any other rocket out there, basically saying, I need to launch something, let's go. They already have a fleet of rockets that are essentially ready to go, or being refurbished to be put back out there. If we can get this word out there, this is an idea that can actually like go up that ladder quickly. So going back to my original point, we are redefining our scientific ladder of ideas, and that hypothesis bucket is now being split into two, right? The bottom bucket is ideas that are exciting, ideas that challenge ways of thinking, like string theory, but they just don't have a test that's able to be done to see if we're even right, right? Because you can question all you want, but at the end of the day, you've got to look at the data and wonder whether you're right at all, right? Am I actually correct? And if you can't do that, then how much energy and effort, and more importantly, money and funding are we going to put towards that thing? Well, not that much, right? Because there isn't any way to test it. And if a new idea comes up in some way that we can test string theory, of course, I'm going to be all about let's put the funding towards it. With something like a testable hypothesis, like Avi's hypothesis, I'm putting much more, like those are the things. It's almost like it's almost like betting on stuff, right? It's almost like, all right, I've got 12 universal credits on Avi's Oumuamua wager, like let's see what's possible, and the amount of money that's already been dumped into things that are not even, that can't even change our daily lives. I'm fully on board that these testable hypotheses, especially in a short window of time, right? Some ideas could be testable, but it would take a very long time for all the tests to be done and for us to figure it out. But if only one spacecraft potentially being launched to go check out some weird object that comes into our solar system that's not part of ours, it's from another star system altogether, I mean, I feel like that's way more important, and something we should fast track towards getting done. And then, of course, theories are things that, they create entire industries, right? Entire industries are created to then drive that tool we've created, that theory, for reality, and then money can be developed from that, right? So the development of a scientific idea is good for everybody, and the quicker we can get them, if they're correct, from hypothesis to theory, the better. And so that was something I just wanted to talk about, because it really did. It was a great conversation, like I said before. I really enjoyed it, and it's got me thinking about. We talk a lot about the funding in aerospace, specifically NASA and rocket technology and spacecraft and stuff like that, and the amazingness that reusable technology like Falcon 9 and soon to be Starship, which was Starship SN11, is already got static fired, so it should be testing this week, right? So we love all that, and we can't not look at the other side of science, which is of course the research, right? That's where everything starts from. Papers and research papers, all of that is where all this comes from. And there are definitely ways that we can get better at that. And I've been amazed by the popularity of this episode, especially how much engagement there's been online, especially from younger than me, I should say, people that are actually in STEM, people that are in there right now learning, or right before they're about to go into college. Those people are really interested in this. And it seems the older it gets, the more people drop off from this idea even being worth their time, or if it's even reaching them in the first place. So it's been a really fun experiment for us, for science communication. That's something we want to do, is obviously promote these scientific ideas. So it was really good just to see that, Avi is dialed into who this message is really reaching, and he mentioned it in our podcast. It is the younger generation, and those are the people that if he can get them, if we can all get more people who can question and think about new things and be open to the possibility of other ideas also being correct and representing reality that changes how we think of things, then another core tenet of science, which is academia and the research that's happening, if we can get them to change, and then also have an industry that like we see with the aerospace industry, where they're being way more accepting of reusable technology, a brand new idea, right? Something that was a pure hypothesis. Elon dumped his money into it. He brought all these talented engineers in to make it happen, and now they just flew their ninth Falcon 9, they flew a Falcon 9 for the ninth time. No one even thought it would happen twice because we were so stuck in the fundamental early ideas of expendable rockets being everything. And we're how can we not be fans of new ideas that make everything better, right? And the great thing is like, even with reusable technology, right, with reusable rockets, it's not like it's eliminating expendable rockets. It's just finding its own place. And now expendable rockets can be used for very specific missions where you need a lot of energy behind an object to get it to a very specific orbit, because reusable rockets can't put as much energy behind something because it needs to keep the fuel it's not using to go land again, right? So there are trade-offs to all this, right? Reusable technology may not be the best option for everything. And I think it's the same thing with this hypothesis from Avi about like, we need to really define like, what are our testable hypotheses? What are the things we can help solve problems or change the way we think that can be done today? And really being good about looking at that stuff, looking through and making sure you find those things so they don't end up in some pile where nobody's looking, right? So those are my thoughts. Those are my thoughts this week. I know a little sporadic, but that is my life. So I hope you enjoy the episode. As always, make sure to spread love and spread science. Check us out on Instagram at Today in Space Pod, Facebook at Today in Space Podcast. We've got a fun community. We're posting a lot of stuff there, so go follow us there. And then, of course, TikTok, Today in Space Pod. And you can help support the podcast by going to ag3dprinting.etsy.com and using us as a place to get gifts for either yourself or a friend or a loved one, whoever it is. We got a bunch of stuff. We 3D print all those models ourselves. A lot of stuff that are functional, a lot of stuff that's fun, and that helps fund everything that we do here. This Shrine of Pi is available on Thingiverse, so it's free. So if you want to download, if you have a 3D printer, you can download this. That's our Thingiverse profile at AG3D Printing. And we're trying to show people what's possible with bringing ideas into reality, right? I've gone down this strange path from being an aerospace engineer, being a maker, and using 3D printers to help other people bring their ideas into reality. And I really want to make sure that we can help teach more people that skill so we can really bring this new way of bringing ideas into reality to as many people as possible. So, and then of course, if you want your own 3D printing done, we have a service bureau here. We can do that for you. So if you have a project, reach out to us at ag3d.engineering@gmail.com. We'll free quote for whatever your project is, and we'll let you know if it's possible. If not, we'll point you in the right direction. But we are trying to get more people involved in science and STEM, and if we can help them with that, if we can be your resource, your expertise for something like that, we're here for you. So spread love, spread science, be well, and we'll see you next time on the next episode of Today in Space.